Okay, guys. Okay, welcome back to be here. And today we will talk about landing gear. And probably you will not find anything about landing gear on YouTube. So this is maybe the first video on the net. Sorry. Okay. So the first thing to say is the reference book I use for this video and are this one. Aircraft Design, a System Engineering Approach, and is at page 500. Yes, 500 is the most interesting part, and this is mainly for calculation, and this book is for construction. I will show you. You see, there is an explanation of all types, and of course the design of the shock absorber, strut, tires, and so on. So it's up to you. Since we are talking in the modelism scale, some aspects are not treated because they are not applicable or too complex. One of these is the choose or the sizing of the shock absorber, because in the market you can find a lot of products based on the weight of your aircraft, but this does not mean that the position, the location of the aircraft are safe if you buy standard products. So first of all, we have some kinematism. We do not enter in this part because just for information of the types of mechanism that you can find in landing gear. So if you want to build one of these, I recommend this book, because treat all the mechanism and the mechanical part and also the dynamic part of the landing gear. Okay, let's go ahead. And first of all, we have two types: in wing and in fuselage. High wing and low wing. Sorry. Of course, you have also the tricycle configuration, and the inverted tricycle, which was used during the World War II. If you have an image of the Spitfire on the other one, are inverted. The calculation is the same, does not change. Okay, so first step, we have the height. Okay, we have the height, the angle of clearance, and the distance from the end. What this mean? This means that if we have, this is our aircraft. Okay. Oh, sorry. Perfect. Yeah, we use this one. Okay. And we have the ground. At this part, there will be the contact point between the main gear and the airplane. This angle is called clearance, alpha clearance, which usually is 15 degrees or less. This distance is a B, and this is the height of the landing gear. So for solve the first step, the formula to apply. Oh, sorry. The formula to apply is alpha C is using this formula. You can find this angle, or if you impose 15 degrees, you can find this the distance from the fuselage of the ground, or the distance from the end fuselage to the connecting point between the landing gear, the fuselage, and the contact point between the landing gear and the ground. Next step is the track. Is the wheelbase. We can see that B is the distance between the front wheel to the main wheel, nose wheel. Okay, you can see that the center of gravity is calculated, so this is a guess, because if you had some weight on the nose, the center of gravity will be in that direction. So this is a trial and error process. You have to calculate your center, then calculate the B, and so on. Okay, the formula we will use is this one. The force of the nose is the weight of the aircraft. B min or B max is the same, which this is the base. The force on the nose usually is between 5 and 20%, and on the main wheel is the remain. So we will see an example here. I will explain the calculation. I will not read because everyone can read. Okay, so we are starting from the formula we saw above. Then we are solving from B because B is our unknown. So then we have that B max is, we can see from here, B max is B minus the distance of the center of gravity. So it's here. The weight, and Fn max is the 50% of the weight. So in the end, this will disappear with this, and by multiplication, just an easy multiplication, we will have these two terms, and then if we solve, we will have that this this value is 1 about 0.50. I will show you. One 0.50. Okay, and this term is this one. So in the end, the base of this aircraft will be 7.6047 meters. Okay, so now we have B. Last part, not the last part. Then the follow part is the track. Track is the distance between two tires on the main gear, and the half is in the correspond to the nose. So for the sizing of this parameter, we have to take into account the maneuverability and stability of the aircraft, because if T is too small, you can understand that there will be some instability, vertical instability, and if T is too large, we will have a belly which will be near of the ground, and we have some dihedral effect, and this is not achievable, not acceptable, sorry. Okay, so what to do next is we have to consider that for track calculation, the maximum angle of turning, this one, is 25 degrees. So the formula is centrifugal force is the V squared and R. V squared is, in this case, we are talking about a landing gear, so we will use the V stall, and R is the turn radius. Sorry. So after some calculation and consideration, taking into account the distance of the ground the ground to the distance from the ground to the center of gravity, track can be calculated with the following formula, which is track 2 FC CG mass and G. This is calculated from as we saw before, with this formula. The height of the center of gravity is an estimate. You will be in a trial and error loop also in this phase. G is 9.5 second. This is the mass in Newton, and this will give the track in meters. last part is the structural integrity, and of course in here, if we have, as we saw before, the track too large or too small, we will have different effects like this with dihedral, and we will have an hedral. Okay, during normal fly the landing gear is up, so we have not problem, but in takeoff condition display these two behaviors plays a important part, sorry. So I will not enter in the details of the structural stability, but I just want to tell you the formula, which is T, which relates the track to the structural integrity, and is 48 I B Y max B max. Okay. E elastic. Oh, sorry. Modulus. I second moment of inertia, and depends on the shape of the main spar. B is the base, which we calculated before. This is the weight in and B max is what is it? B. Oh, I deleted. Okay, no problem. Yeah, I delete. Is the distance we'll choose, and we will see here. Okay. B max is B yeah, B main max, sorry. This value is Y max is the maximum allowable deflection. Max deflection, and this can be calculated like with this formula: F length 48 EI. F is the force applied to the beam, which in this case is our main spar, and L is the length. Sorry. This is L. These are the mechanical properties of the main spar. So if you are choosing this shape, you will look for the second moment of the inertia of this shape. If you are using a T, I don't think so, but you can. Also we have this one, cylindrical. Every shape has a second moment of inertia. So this is all, and I hope that this can be useful for you. And if you have some questions, just ask, and I will answer every kind of question. Just one thing I saw in this part, V-stall is calculated using the well-known formula. Okay, and of course you will do some consideration when you use this one, and especially the lift coefficient. So thanks for watching, and see you next time. Bye.